Okay, so we figured out that each day you're adding whatever the figure number is. That's how many new squares that you get. And so we figured it out that way. And so each number, like, so this was the third. So to get the fourth, you add 4 to that. To get the fifth, you add 5 to that. And then 6. And then 7. And then 8. And then 9. And then 10. And then 11. And I heard a whole lot of people say they got 286, which was right. Right, and then because you did all that on number 4, I heard a bunch of people figuring out what to do on number 5. So we know how many on day 52. What would I do to that to get day 53? Perfect. All right, and so for 6, what's the rule for getting from one figure to the next? What do you add?
I put previous figure number plus new figure.
Yes, so sure, previous figure amount plus figure number. Now that's a special type of rule that you guys did learn about in Algebra 2, where you take a previous term and you do something to it. Do you know what that was called? It's okay. It's recursive. So a super famous recursive sequence is the Fibonacci sequence. Fibonacci, I think, is the yellow guy back there by Wade. So he did a sequence that's famous, but that's when you take a previous term, or it could do multiple previous terms to get the next one. Okay, so on the back, we're going to fill in these notes. I didn't make this box quite big enough. I should have expanded it a little bit, but we'll see. We can squeeze it all in there. All right, so we're going to say that A sub n is a sequence where n is the term number. I think I might have said m. I meant to say n. And A sub n is the term value. So A sub n is kind of like f of x. So f of x we use when we are representing a function. We put numbers in for x. A sub n is kind of like a function for a sequence where you put numbers in for n. And there's 2 types of rules that we can write. One is called the explicit rule, which is more what we did on Friday, which some of you missed, but that's okay. You'll catch up. It'll be fine. And then the other rule is a recursive rule, which is like what we did on the other side. So explicit rules do not depend on previous terms.
What is that between the rules and not? What's that?
Explicit.
Oh, that's
do. Sorry. So an example of an explicit rule would be like A sub n equals 3n plus 5. N is the term number. What we get when we plug in that term number is the term value. So let's say we wanted to find the second term. What would you plug in for n to find the second term? You would plug in 2. Good. So it would be 3 times 2 plus 5. So the second term would be 11. Those are explicit rules, and they're probably the easiest to work with out of the 2 types. If you'll just put that on that table back there. Thank you. All right, and then the other type of rule is recursive. And recursive rules do depend on previous terms. Thank you. In a recursive rule, you are required to have two parts. You can't just have a single part like an explicit rule. So on a recursive rule, they have to tell you the first term, or at least a term. Usually it is the first term. So we'll say in this rule, a sub 1 is 5. And then they tell you how to get another term. So a sub n would be whatever you do to get the nth term. And then we have a sub n minus 1. Do you guys know do you remember what that means? A sub n minus 1. It means previous term. Good job. So you take the previous term and do something to it. So we're going to add 3 to the previous term. Okay, so let's say I want to find the second term again. So I'm still finding a sub 2. It's a totally different sequence, so we're going to get a totally different number. All right, what would I do to find the second term? Take the previous term, which would be 5. And what would I do to it? Add 3 to it. So in this time, the second term is 8. So those are the two different types. So anytime you see a sub 1, it means previous term. Okay, and then today we're going to talk a tiny bit about series. And so a series is when you add up the terms of a sequence, which is what you guys did on number 4 over here. You added up all, not number 4, yeah. You added up all those squares. So we are going to do summations. So a series is the sum of the terms of a sequence. And you guys might remember summation notation. All right, so the rule for a sequence is usually a sub something. The rule, or what you use to notate a sum, is usually s sub something. So s sub n. So let me show you what this summation notation looks like. The summation symbol is the Greek letter sigma. It's capital sigma. It looks kind of like an E. You've definitely seen this before. All right, I'm going to use I as my index. And so underneath the summation, I have I equals 1. And at the top, we're going to just represent n. So what this means is you start by plugging in 1, and then you plug in 2, and then you plug in 3, and then you plug in 4, and you keep plugging in the number until you get to whatever is up here. So the bottom is where you start, and then you go up by 1 until you get to the top. So our little rule is just a generic rule. We're going to call it a sub I. So we plug in 1 plus plug in 2 plus keep plugging in until you get to plugging in n. And we'll do an example of that without all the symbols. It'll make more sense. All right, so let's do some examples. So on 1, we have explicit rules we have 2 of them, and we're going to find the first 4 terms. So the first term is always a sub 1. And when you have the explicit rule, what do we put in for n to find the first term? Just put in 1. So that's going to be 1 squared plus 2, which is 3. And then to find the second term, we put 2 in for n. So 2 squared plus 2, which is 6. And then third, we'll plug in 3, square it, and add 2. And then 4, whoops, I went ahead and squared it in my head. Square 4, and then add 2. And that's it. So the explicit rule is pretty easy to use. Now B is kind of a strange sequence, but we can still do it the same way. So to find the first term, we're going to put 1 in for both of our n's. So we have negative 1 to the 1 over 1. So negative 1 to the 1 is negative 1. Divided by 1, it's still negative 1. Right. And then for the second term, we're going to put 2 in for both of our n's. What do you get when you square negative 1? Negative 1? Positive. A negative times a negative is a positive, so that's going to be 1/2, positive 1/2. All right, and then we'll put 3 in for both ends. What about negative 1 cubed? Yes. So when you have a negative raised to an odd power, it's negative. When it's raised to an even power, it's positive. All right, so for number 3, sorry, just kidding. For number 2, we are going to find the 7th term. That's what a sub 7 means. And then we're going to find the rule, the explicit rule. All right, so to get the first term, I'm going to plug 1 into something, and I'm going to get 3. And then I'm going to plug 2 into the same thing, and I'm going to get 6. I'm going to plug 3 into the same thing, I'm going to get 9. So what am I doing to those numbers? Not adding 3. Multiplying by 3. So when I plug in 7, what should I get? Yes. So then my rule is just 3 in. 3 times whatever term number it is, gives you the term. All right, B is a little more difficult. So we want to find the 7th term. Can you tell what the numerator is going to be? Definitely going to be 5. Now, even though 1 doesn't look like a 5, 1 is technically 5 over 5. So if you want to write 5 over 5 over your 1, it might help. So my numerator, 100% is going to be 5. So we need to worry about the denominator. So when I plug in 1 to my denominator, I got 2. And when I plug in 2, I got 3. And when I plug in 3, I got 4. So when I plug in 8, when I plug in 7, what should you get? I shouldn't have given that away. Dang it. Thanks. So what should my rule be? N plus 1 in the denominator. So 5 on the top, n plus 1 in the denominator. That was good. Unfortunately, I ruined it a little bit. Okay, that is explicit rule. That means you just plug in the term number and it gives you the term. On number 3, we're going to do a recursive rule. And so when you do a recursive rule, you have to tell what the first term is. So you have to tell, on this one, a sub 1 is 25. It's required. And then what are we doing to a previous term to get the next one? You're subtracting 7 each time. Okay, so a sub n is going to equal however you represent the previous term, which we said right here, a sub n minus 1. And then minus 7. So you're telling to take the previous term, subtract 7. It gives you the next term. All right, on number 4, that is summation notation. And we're going to write it out. There is a way for your calculator to do it. We're not doing that today, but you'll remember as soon as you find it in the calculator. But I'm going to actually write out what you do. So we start with 1 and we put it in for I. And so it's going to be 3 times 1 minus 1. And to that, you're going to add, go to the next number, which is 2. Put it in for I, so 3 times 2 minus 1. And then we put in 3. And then we put in 4. And when do we stop?
When you get the 5.
Yeah, you stop when you get to that top number. All right, so this is going to be 2 plus 5 plus 8 plus 11 plus 14, which is 40.
You just added 3.
So what?
So you just added 3.
It did. That's because basically the slope is 3. I like it when you guys see these patterns. Okay, now if you weren't here Friday, you might just be slightly behind everybody else on doing this last one just because we practiced these Friday, but I think you're going to be fine. And so we have 3 figures that represents a pattern. And so the answer or the question is, how many squares will there be in figure 43? We are not going to draw a figure 43. We're going to figure it out. And so this first one has 1 row and 2 columns. What about the next one? 2 rows and 4 columns. And this one? Okay, so look at the figure number and the things. Yes. So what do you guys notice about the rows and the figure number? They're the same, right? Rows and the figure number are the same. What about the rows and the number of columns? But look at, you're right. What I want you to look at now is like the 4 and the 2, and the 2 and the 1, and the 6 and the 3. It doesn't add to, it multiplies by 2. It doubles it. So if we wanted to write a rule for any figure, you would take the number of rows, which is going to match the figure number, and multiply it by twice that for the columns. So it's going to be 43 times 86.
That's a lot.
It's a lot of squares. All right. What questions do you guys have? Okay. We'll practice this tomorrow.